Monsters of the cosmos. The impossible supermassive black hole. At the center of a galaxy so distant we see it as it was just 690 million years after the Big Bang, lies a cosmic paradox. A supermassive black hole, with a mass of 800 million suns. Its existence is a profound challenge to our understanding of the early universe. Black holes grow by accreting matter, but this process takes time. There's a speed limit. For this black hole to have grown so massive, so quickly, it would have had to consume matter at the maximum theoretical rate for its entire existence, from the moment it was born. That seems highly unlikely. So how did it get so big, so fast? Was it born from the direct collapse of a gigantic cloud of primordial gas, creating a seed black hole that was already thousands of times the mass of our sun? Or did it form through the merger of many early dense star clusters? This ancient Leviathan forces us to rewrite the story of how the first monsters of the cosmos came to be. The cosmic forges, neutron-star collisions. Deep space is home to the universe's most extreme alchemy. It doesn't happen in the hearts of stars, but in the final, catastrophic embrace of two dead stars, neutron stars. Each is the corpse of a massive star, a city-sized object, so dense that a single sugar cube-sized piece of it would weigh as much as all of humanity. They are made almost entirely of neutrons, packed together like a giant atomic nucleus. When two of these incredible objects spiral into each other, they don't just collide, they rip each other apart in a cataclysm called a kilonova. The violence is unimaginable. For a few seconds, it outshines all the stars in a billion galaxies, and in that maelstrom, neutrons are captured at a ferocious rate, building up the heaviest elements in the periodic table. It is here, in these cosmic collisions, that the universe forges gold, platinum, silver, and the uranium that powers our nuclear reactors. The wedding ring on your finger, the platinum in a lab device, were born in a fireball that briefly outshone the cosmos, from the death spiral of two stellar ghosts. The Boötes Void, incendiarial, null void. A universe of nothing. Space is mostly empty, but some places are emptier than others. Far, far emptier. Meet the Boötes Void, a spherical region of space 330 million light-years across. To put that in perspective, if you were at its center, you would need to travel for 330 million years at the speed of light to reach the other side. In a volume of space that large, our standard models of the universe predict there should be around 2,000 galaxies. But when astronomers point their telescopes at the Boötes Void, they see almost nothing. Only 60 galaxies have been found. That's a cosmic desert on a scale that is almost incomprehensible. If our Milky Way were at its center, we would not have known other galaxies existed until the space age. What could cause such a vast nothingness? Was it the result of a collision between bubbles in the early universe's structure? Is it the imprint of some exotic physics involving dark energy? Or is it, against all odds, just a staggering 1 in a billion fluke? The void doesn't just scare us with its emptiness, it challenges our very models of how the universe is structured. Magnetars, the magnetic monsters. If a neutron star is a cosmic zombie, a magnetar is a neutron star possessed by a demonic force. It's a type of neutron star, but with a magnetic field 1,000 trillion times more powerful than Earth's. The magnetism is so intense, it warps the very atoms surrounding it, stretching them into long, needle-like shapes. If you were to venture within 1,000 kilometers of a magnetar, the magnetic field would literally pull you apart, ripping the electrons from your atoms. But their true terror is revealed in their starquakes. As the magnetar's impossibly rigid crust shifts, it releases colossal flares of gamma rays. In 2004, a magnetar flare from 50,000 light-years away was so powerful that it compressed Earth's magnetosphere, partially ionizing our upper atmosphere. If one of these events happened within 10 light-years of Earth, it would strip away our ozone layer and trigger a mass extinction. These are not just dead stars, they are sleeping dragons, wielding the most powerful magnetic forces in the universe. The Lonely Wanderers. Rogue planets. Forget planets orbiting stars. The galaxy may be teeming with a hidden population of outcasts. Rogue planets. These are worlds that were born in solar systems like our own, but were gravitationally kicked out in the chaotic dance of planetary formation. They are orphans, cast adrift into the cold, dark interstellar space. With no sun to warm them, their surfaces are frozen wastelands, just a few degrees above absolute zero. But life, if it exists, would not be on the surface. A large rogue planet, with a thick hydrogen atmosphere, could trap enough internal heat from its radioactive core to maintain a vast, subsurface ocean of liquid water, insulated from the cold of space by a thick shell of ice. In these sunless seas, around hydrothermal vents, life could potentially arise and thrive, completely isolated, forever journeying through the galaxy without a star to call home. These dark wandering worlds could be the most common abodes for life in the universe, and we would never know they were there.